In this lesson, you'll get a full overview of how to set up both a basic and advanced RAG pipeline with Llama Index. We'll load in an evaluation benchmark and use TrueLens to define a set of metrics so that we can benchmark advanced RAG techniques against the baseline or basic pipeline. In the next few lessons, we'll explore each lesson a little bit more in depth. Let's first walk through how a basic retrieval augmented generation pipeline works, or RAG pipeline. It consists of three different components: ingestion, retrieval, and synthesis. Going through the ingestion phase, we first load in a set of documents. For each document, we split it into a set of text chunks using a text splitter. Then for each chunk, we generate an embedding for that chunk using an embedding model. And then for each chunk with embedding, we offload it to an index, which is a view of a storage system such as a vector database. Once the data is stored within an index, we then perform retrieval against that index. First, we launch a user query against the index, and then we fetch the top k most similar chunks to the user query. Afterwards, we take these relevant chunks, combine it with the user query, and put it into the prompt window of the LLM in the synthesis phase, and this allows us to generate a final response. This notebook will walk you through how to set up a basic and advanced RAG pipeline with Llama Index. We will also use TrueArrow to help set up an evaluation benchmark so that we can measure improvements against the baseline. For this quick start, you will need an OpenAI API key. Note that for this lesson, we'll use a set of helper functions to get you set up and running quickly, and we'll do a deep dive into some of these sections in the future lessons. Next, we'll create a simple LLM application using Llama Index, which internally uses an OpenAI LLM. In terms of the data source, we'll use the How to Build a Career in AI PDF written by Andrew Wright. Note that you can also upload your own PDF file if you wish, and for this lesson, we encourage you to do so. Let's do some basic sanity checking of what the document consists of, as well as the length of the document. We see that we have a list of documents. There's 41 elements in there. Each item in that list is a document object. And we'll also show a snippet of the text for a given document. Next, we'll merge these into a single document because it helps with overall text splitting accuracy when using more advanced retrieval methods, such as the sentence window retrieval, as well as the auto-merging retrieval. The next step here is to index these documents. And we can do this with the vector store index within Llama Index. Next, we define a service context object, which contains both the LLM we're going to use, as well as the embedding model we're going to use. The LLM we're going to use is GPT 3.5 Turbo from OpenAI, and then the embedding model that we're going to use is the Hugging Face BGE Small model. These few steps show this ingestion process right here. We've loaded in documents, and then in one line, vector store index.from documents, we're doing the chunking, embedding, and indexing under the hood with the embedding model that you specified. Next, we obtain a query engine from this index that allows us to send user queries that do retrieval and synthesis against this data. Let's try out our first request. And the query is, what are steps to take when finding projects to build your experience? Let's find out. Start small and gradually increase the scope and complexity of your projects. Great, so it's working. So now you've set up the basic RAG pipeline. The next step is to set up some evaluations against this pipeline to understand how well it performs, and this will also provide the basis for defining our advanced retrieval methods, the sentence window retriever, as well as the auto-merging retriever. In this section, we use TrueLens to initialize feedback functions. We initialize a helper function, get feedbacks, to return a list of feedback functions to evaluate our app. Here, we've created a RAG evaluation triad, which consists of pairwise comparisons between the query, response, and context. And so this really creates three different evaluation modules: answer relevance, context relevance, and groundedness. Answer relevance is the response relevant to the query. Context relevance is the retrieved context relevant to the query. And groundedness is the response supported by the context. We'll walk through how to set this up yourself in the next few notebooks. The first thing we need to do is to create a set of questions on which to test our application. Here, we've pre-written the first 10, and we encourage you to add to the list. And now we have some evaluation questions. What are the keys to building a career in AI? How can teamwork contribute to success in AI? Etc. The first thing we need to do is to create a set of questions on which to test our application. Here, we've pre-written the first 10, but we encourage you to also add to this list. Here, we specify a fun new question: what is the right AI job for me? And we add it to the eval questions list. Now we can initialize the TrueLens modules to begin our evaluation process. We've initialized the TrueLens module, and now we've reset the database. We can now initialize our evaluation modules. LLMs are growing as a standard mechanism for evaluating generative AI applications at scale. Rather than relying on expensive human evaluation or set benchmarks, LLMs allow us to evaluate our applications in a way that is custom to the domain in which we operate and dynamic to the changing demands for our application. Here, we've pre-built a TrueLens recorder to use for this example. In the recorder, we've included the standard triad of evaluations for evaluating RAGs: groundedness, context relevance, and answer relevance. We'll also specify an ID so that we can track this version of our app. As we experiment, we can track new versions by simply changing the app ID. Now we can run the query engine again with the TrueLens context. So what's happening here is that we're sending each query to our query engine, and in the background, the TrueLens recorder is evaluating each of our queries against these 3 metrics. If you see some warning messages, don't worry about it. Some of it is system dependent. Here we can see a list of queries as well as their associated responses. You can see the input, output, the record ID, tags, and more. You can also see the answer relevance, context relevance, and groundedness for each row. In this dashboard, you can see your evaluation metrics like context relevance, answer relevance, and groundedness, as well as average latency, total cost, and more in a UI. Here, we see that the answer relevance and groundedness are decently high, but context relevance is pretty low. Now, let's see if we can improve these metrics with more advanced retrieval techniques like sentence window retrieval, as well as auto-merging retrieval. The first advanced technique we'll talk about is sentence window retrieval. This works by embedding and retrieving single sentences, so more granular chunks. But after retrieval, the sentences are replaced with a larger window of sentences around the original retrieved sentence. The intuition is that this allows for the LLM to have more context for the information retrieved in order to better answer queries, while still retrieving on more granular pieces of information. So ideally improving both retrieval as well as synthesis performance. Now let's take a look at how to set it up. First, we'll use OpenAI GPT 3.5 Turbo. Next, we'll construct our sentence window index over the given document. Just a reminder that we have a helper function for constructing the sentence window index, and we'll do a deep dive in how this works under the hood in the next few lessons. Similar to before, we'll get a query engine from the sentence window index. And now that we've set this up, we can try running an example query. Here the question is, how do I get started on a personal project in AI? And we get back a response. To get started on a personal project in AI, it is first important to identify and scope the project. Great. Similarly to before, let's try getting the TrueLens evaluation context and try benchmarking the results. So here, we import the true recorder sentence window, which is a pre-built TrueLens recorder for the sentence window index. And now we'll run the sentence window retriever on top of these evaluation questions, and then compare performance on the RAG triad of evaluation modules. Here we can see the responses come in as they're being run. Some examples of questions or responses. How can teamwork contribute to success in AI? Teamwork can contribute to success in AI by allowing individuals to leverage the expertise and insights of their colleagues. What's the importance of networking in AI? Networking is important in AI because it allows individuals to connect with others who have experience and knowledge in the field. Great. Now that we've run evaluations for two techniques, the basic RAG pipeline as well as the sentence window retrieval pipeline, let's get a leaderboard of the results and see what's going on. Here, we see that generally groundedness is 8 percentage points better than the baseline RAG pipeline. Answer relevance is more or less the same. Context relevance is also better for the sentence window query engine. Latency is more or less the same, and the total cost is lower. Since the groundedness and context relevance are higher, but the total cost is lower, we can intuit that the sentence window retriever is actually giving us more relevant context and more efficiently as well. When we go back into the UI, we can see that we now have a comparison between the direct query engine, the baseline, as well as the sentence window. And we can see the metrics that we just saw in the notebook displayed in the UI as well. The next advanced retrieval technique we'll talk about is the auto-merging retriever. Here, we construct a hierarchy of larger parent nodes with smaller child nodes that reference the parent node. So for instance, we might have a parent node of chunk size 512 tokens, and underneath, there are 4 child nodes of chunk size 128 tokens that link to this parent node. The auto-merging retriever works by merging retrieved nodes into larger parent nodes, which means that during retrieval, if a parent actually has the majority of its children nodes retrieved, then we'll replace the children nodes with the parent node. So this allows us to hierarchically merge our retrieved nodes. The combination of all the child nodes is the same text as the parent node. Similarly to the sentence window retriever, in the next few lessons, we'll do a bit more of a deep dive on how it works. Here, we'll show you how to set it up with our helper functions. Here, we've built the auto-merging index, again, using GPT 3.5 Turbo for the LLM, as well as the BGE model for the embedding model. We get the query engine from the auto-merging retriever. And let's try running an example query. How do I build a portfolio of AI projects? In the logs here, you actually see the merging process go on. We're merging nodes into a parent node to basically retrieve the parent node as opposed to the child node. To build a portfolio of AI projects, it is important to start with simple undertakings and gradually progress to more complex ones. Great, so we see that it's working. Now let's benchmark results with TrueLens. We get a pre-built TrueLens recorder on top of our auto-merging retriever. We then run the auto-merging retriever with TrueLens on top of our evaluation questions. Here, for each question, you actually see the merging process going on, such as merging 3 nodes into the parent node for the first question. And if we scroll down just a little bit, we see that for some of these other questions, we're also performing the merging process, merging 3 nodes into the parent node, merging 1 node into the parent node. An example question response pair is, what is the importance of networking in AI? Networking is important in AI because it helps in building a strong professional networking community. Now that we've run all 3 retrieval techniques, the basic RAG pipeline, as well as the 2 advanced retrieval methods, we can view a comprehensive leaderboard to see how all 3 techniques stack up. We get pretty nice results for the auto-merging query engine. On top of the evaluation questions, we get 100% in terms of groundedness, 94% in terms of answer relevance, 43% in terms of context relevance, which is higher than both the sentence window and the baseline RAG pipeline. And we get roughly equivalent total costs to the sentence window query engine, implying that the retrieval here is more efficient with equivalent latency. And in the end, you can view this in the dashboard as well. This lesson gives you a comprehensive overview of how to set up a basic and advanced RAG pipeline, and also how to set up evaluation modules to measure performance. In the next lesson, Anupam will do a deep dive into these evaluation modules, specifically the RAG triad of groundedness, answer relevance, and context relevance. And you'll learn a bit more about how to use these modules and what each module means.